This video we're going to try to help you understand Lewis diagrams. So we're doing Lewis structures, sometimes called Lewis diagrams. They follow the movement of valence electrons. And in group 1, there's one valence electron. Group 2, there are 2. In group 13, there are 3, 14, 4, 15, 5, 16, 6, 17, 7, and 8 for group 18, with the exception of helium. Helium can only have 2 because its energy level only accommodates 2 electrons. And so if we were to draw some atoms that had Lewis structures, we would maybe pick potassium that's in group 1. It has 1 valence electron. Calcium in group 2 has 2 valence electrons. And then gallium, which is in group 13, has 3 valence electrons. Germanium in group 14 has 4 valence electrons. And arsenic in group 15 has 5. And once you get to 5, you fill in the 4 sides and you make a pair. Your selenium is in group 16, so it has 1, 2, 3, 4, 5, 6. Bromine has 7 because it's in group 17. And finally, you'd have your krypton has 8. Now, krypton is very stable because it has a full octet. And we say when the valence shell is full, it has a full octet. You might use that term for helium when it has 2, because again, helium can only accommodate 2 electrons in its valence shell. Now, this is how we would select the number of valence electrons for different atoms. When they occur in pairs like this, they are called lone pair electrons. And when you have a single electron by itself, it's called a bonding electron. So bromine has 1 bonding electron, and so does potassium. Calcium has 2, gallium has 3, germanium has 4, arsenic has 3 bonding, selenium has 2. But our arsenic has 1 lone pair, selenium has 2. And krypton is totally stable because it has 8, it has a full octet. Now, that counts for atoms. And when we're trying to decide on what happens in an ionic compound is made out of ions. And it can be helpful for us to understand a reaction, let's say a formation reaction of magnesium, which has the 2 valence electrons, because magnesium is in the second group, reacting with fluorine. Now, fluorine is a diatomic element. A fluorine atom has 7 valence electrons, and it is bonded to another fluorine that has its own 7 valence electrons. And this fluorine is a molecule. So it's a molecular element. This fluorine has 7 of its own plus 1 to make 8. This one has 7 of its own plus 1 to make 8. And this is a covalent bond where the electrons are being shared. But magnesium doesn't really want these electrons. It would rather donate them, because magnesium has an electronegativity of 1.3 and fluorine has an electronegativity of 4.0. Fluorine wants these electrons so badly that it will pull them off of magnesium, and magnesium is not fighting it. It wants to get rid of them. The magnesium will give an electron to the fluorine and to the other fluorine. And what happens is your magnesium becomes a magnesium ion, and you have a fluoride ion that has 1 valence electron from the magnesium. And so now it's got a full octet. It's much more stable, like noble gas, but now it's got a -1 charge. And you'll get another fluoride that's taken its electron also from the same magnesium, and it has a -1 charge as well. So we end up with MgF2 or magnesium fluoride, and it's an ionic compound with a ratio of 1 magnesium ion to 2 fluorides. So that's the start of Lewis structures. We'll do another video in a second on making molecular compounds using Lewis structures, so we can follow where the electrons are in our molecular structures.